Generally, shell and tube heat exchangers involve a large number of tubes, and due to the presence of baffles, cross-flow situation is encountered, and where the flow is normal to the tubes, and that's the part that we are going to evaluate here. We're going to assume we have a bundle of tubes, and we're going to find the overall heat transfer, convective heat transfer coefficient for a bundle of tubes, and that's very important. This is important in heat exchangers, as we will see later on. So there could be different configuration of tubes. They can be aligned as a square pitch. Could have where the tubes are aligned, or we can have a staggered tube or triangle in triangle configuration pitch. So for this square one, just schematically, these are the tubes. The distance between each row of this tube, we call it SL. The distance here is transfer. The diameter of tube we assume is D for these situations, and let's say there is a uniform flow crossing these tubes. And for the staggered one, what we can have is, let's say here, so the same thing, the distance between these two, longitudinal and ST. When the flow passing, just schematically, this can be the flow that's passing through the tube of heat exchanger. So I'm mixing here. The same thing can happen in the other configuration. So the first one is a square pitch, or what we call it, the aligned tubes, and staggered tube bundle, or aligned tube bundle, tube bundle. Now in the schematic that I'm drawing, just emphasize ST is the spacing normal flow, call it transverse pitch, and SL is the spacing parallel to the flow or longitudinal pitch. D is the diameter of tubing in either of the configuration, and we assume all the tubes have the same diameter. So this is tube diameters, and average heat transfer coefficient. The average. Coefficient over the entire bundle. One of the correlations, which is empirical correlations, is average Nusselt number. D is C1 Reynolds number D and max. And we'll discuss like what is this Reynolds number D and max to the power of M. Prandtl number to the power of 0.36, which is corrected to PRS to the power of 1/4. And this is valid for when the number of bundles in the direction of the flow is greater than 20. Prandtl number is less than 500, greater than 0.7. And for the Reynolds number of D and max, the maximum Reynolds number that we can have in the system, 2 times 6, greater than 10. Now, there are other correlations existing that you can see in various references. C1 and M depends on the configuration, whether we have this is staggered or aligned, the spacing configuration, this SL and ST, and tube diameter. D. And we can find the values for CA1 and M for different situations in the table in your text. Now for NL less than 20, then there is a correction factor that we need to use. The another assumptions that we are making here is temperature, surface temperature of the tubes is constant, and so TS surface temperature of tubes is constant. So all the tubes have the constant temperature of TS. Now in this equation, PRS is evaluated at TS, Prandtl number at TS. Other properties are evaluated at the average inlet and outlet temperatures. Ti plus To divided by 2. So if let's say we have this tubing, this bundle of tube, let's say the inline bundle of tubes, and let's assume this is just a few of them that I'm showing here. So there are many of these rows that has been built up. So if I label them 1, 2, and all the way, this is going to be NT. So NT, what it means is the number of tubes in each row. So NT is number of tubes in each row. And if I label in the other way, we are going to reach to NL. So NL represents the number of tubes, number of actually tube row that we have. So NL is the number of tube rows. Remember that this equation, we were saying this is valid for NL greater than 20. So the number of rows that we would need to have is all the way is going to be from 1 to all the way to 20. So we should have a heat exchanger with the 20 or more of these rows to use that equation. Otherwise, we need to do corrections. So we have NL, we have NT, and N is the total number of tube. Is the total number of tubes.